Hello there, Narek is here. Today I'm gonna solve the first exercise of the first session from 2019 related to chemistry. It's an exercise which talks about the atoms in general. So manufacture of glass, let's start directly. The principle of manufacturing glass and the raw materials used had almost been the same since thousands of years. The constituents of glass vary according to the type of glass manufactured. The most common raw materials of glass are mainly silicon oxide, silica, SiO2, calcium oxide, CaO, and sodium oxide Na2O. Pick out from the text the names of the raw materials used in the manufacture of glass. You simply have to write down that you have silicon oxide, calcium oxide, and sodium oxide as the raw materials used in the manufacture of glass. You have to write down the names. Document 1 shows the Lewis structure of the silica molecule SiO2. By referring to document 1, answer the following questions. Specify the column or group to which silicon, Si, belongs in the periodic table. So I'm going to write down the formula of SiO2. So this is 2.1. We have Si making a double covalent bond with the first oxygen and another double covalent bond with another oxygen. So as you can see, you have two double covalent bond with two oxygens. So silicon, actually Si, has 4 electron valence electrons. So in this case, you can say that Si actually belongs to group 4 or column 14. Okay, so this was the first question. Choose the valence of oxygen atom in silica, justify. In this silica molecule SiO2, as you can see, oxygen is sharing a pair of electrons. So we have 2 electrons which is shared by the oxygen. So in this case, the valence of oxygen will be 2. You have to justify, so you can say that this is 2.2. Oxygen shares a pair of electrons with Si, so its valence is 2. Quicklime is the name given to the ionic compound calcium oxide, CaO. So CaO is an ionic compound. Document 2 represents the equation of formation of calcium ion, Ca2+, and electron configuration of this ion. So in document 2 you have Ca, which is being transformed into ion Ca2+ by losing 2 electrons, and the electron configuration of calcium ion is K2L2M2. Answer by true or false, justify. The nucleus of calcium atom, Ca, and its corresponding ion have the same composition. It's true. The nucleus will not change. The number of protons and the number of neutrons will remain the same. What I'm exchanging is actually the electrons. So protons and neutrons are preserved, are conserved. That's why the nucleus of the calcium atom and its corresponding ion have the same composition. This is true. You can simply say that. This is 3.A. The number of protons and neutrons in the nucleus of Ca atom and Ca2 plus ion is conserved. It will not change. Now the number of electrons in calcium Ca2 plus is equal to 20. Ca2 plus, you already have the electron configuration, which is K2L2M8. So if you calculate 2 plus 8, it will be 18, which is different than 20. So in this case, you have to say that this is false. So this is 3b, which is false. In this case, you have electron configuration of Ca2 plus is K2L8M8. So the number of electrons will be equal to 18, which is different than 20. All right. What about the atomic number of calcium element is Z is equal to 20? Yes, in this case it's 20. So this is 3C. It's true. Actually, you have Ca2 plus ion has lost 2 electrons. So I can say that the number of electrons in Ca atom is 18 plus 2, which is equal to 20. Now, what about the last question? Explain how oxygen atom attains stability in each of the compounds calcium oxide, CaO, and silicon dioxide, SiO2. Now, the first case, CaO, it's an ionic compound. So you have Ca, which is losing 2 electrons, and oxygen, which is gaining 2 electrons. So you will obtain Ca2 plus and O2 minus. You will have a mutual attraction between these 2 ions, and of course the formation of this stable compound, which is CaO, of course, by verifying the octet rule. As for silicon dioxide, SiO2, in this case you do not have electrons which are exchanged, you have electrons which are shared. So in silicon dioxide, each atom of oxygen is sharing a couple of electrons with silicon, and of course you have double covalent bond which are formed in this compound, and of course we are also verifying and using the octet rule in this case also. So this is how you explain the stability of each compound. For CaO, you have the exchange of electrons, again in order to verify the octet rule. As for SiO2, you have the electrons which are shared, again to verify and to verify the octet rule. That's all for this exercise. This was the first exercise from the first session from 2019 chemistry. I hope it was helpful, and I will ask you to subscribe to my channel because I will be uploading new videos and new material related to, again, solving other sessions. Maybe the following video will be the second exercise, sorry, from this session, which I will upload it in the next in the coming session. So I can also share with you my Instagram, Facebook account. You can contact me directly, and you can also leave a comment if you like. That's all for this time, and hope to see you next time.